Welcome to the deep dive. Today we're going to be looking into concrete.
Oh, fun.
Yeah, specifically we're going to be doing a deep dive on this handbook on concrete mixes based on Indian standards.
Okay. Yeah.
And it's interesting, we all see concrete every day,
Right.
but I don't think most people realize how complex it actually is.
Yeah, it's one of those things like, we just take for granted.
Totally.
Like it's just there and it's always been there, but there's a lot more to it.
Yeah, and this handbook actually breaks it down into 4 key components.
Okay.
Cement, aggregates, water, and admixtures.
Right. So it's not just like, throw some stuff together and you're good.
Yeah, it's not just chuck it in a bucket and hope for the best.
Exactly. Like there's a real science to it.
Right, so let's start with cement.
Okay, sure.
What are some of the different types of cement that are out there?
Well, like when you think about cement, you probably just think about the regular stuff.
Mm-hmm.
But there are actually a bunch of different types. Like, for example, there's ordinary Portland cement, which is kind of like your standard go-to.
Uh-huh.
But then you have things like rapid hardening cement if you need something to set really quickly.
Oh, interesting.
Yeah, like imagine you have to repair a runway or something like that.
Oh, right, so you needed to
You need it to set fast.
set fast, yeah.
Exactly. And then on the other end of the spectrum, you have low heat cement,
Okay.
which is, used for massive structures like dams.
Oh, wow. So I can see how that would be important.
Yeah, because when concrete sets, it actually generates heat.
Oh, does it?
Yeah, so for really big things, you don't want too much heat building up.
Oh, wow. That makes a lot of sense.
So yeah, the type of cement you use can make a big difference.
Okay, so cement is obviously a critical ingredient.
Uh-huh.
But what about the aggregates?
Aggregates are really interesting, actually.
Okay.
Like they kind of like the unsung heroes of concrete.
How so?
Well, they make up most of the volume.
Right.
And they have a huge impact on the properties of the concrete.
So it's not just any old rock will do.
Exactly. Like
Yeah.
you have to think about things like the size and shape of the aggregate.
Okay, so what are we talking about here?
Well, first you have the grading, which is like the distribution of different sizes.
Right.
You need a good mix of fine aggregates like sand and coarse aggregates like gravel.
Mhm.
And then there's the shape, are they rounded, irregular, angular?
Oh, right, yeah.
That affects how well they pack together, which influences the strength.
So would smaller aggregates like sand always be better then? Wouldn't that make it denser?
You'd think so, right? But actually, if you use only fine aggregates, it would require a ton of cement paste to fill all the tiny gaps.
Oh, so it would be
Super expensive.
yeah.
And it could actually make the concrete more brittle.
Oh, interesting. So it's all about finding that balance.
Exactly.
Okay, so we've got cement, we've got aggregates. What about the water?
Water is important, too. It's what makes the whole hydration process happen.
Right, the chemical reaction that makes the concrete harden.
Yeah, but the thing is, even small amounts of impurities in the water can cause problems.
Like what?
Things like sulfates and chlorides.
Oh, so if you use salt water to make concrete, that would be bad.
Yeah, exactly. Eventually, those salts could corrode the steel reinforcements inside the concrete.
And then it would
Start to crack and weaken.
wow. So even the water needs to be carefully considered.
Definitely. You don't want to use just any old water.
So we've got the big 3, cement, aggregates, and water.
Right.
What about these admixtures I keep hearing about? What are those all about?
Admixtures are kind of like the special sauce of concrete.
Oh, okay.
They're these ingredients that you add to tweak the properties of the mix.
Like adding spices to a recipe.
Exactly. Like some admixtures can speed up the setting time.
Oh, so if it's cold out and you need the concrete to harden faster?
Exactly. And then there are retarders that slow down the setting time.
Which will be good in hot weather, I guess.
Yeah, you don't want it to set too quickly in the heat.
So you've got a whole toolbox of these admixtures to fine-tune the concrete.
Yeah, it's pretty amazing how much you can control the properties with these admixtures.
Wow, it's incredible how much goes into something as seemingly simple as concrete.
Right. It's a lot more complex than people realize.
So we've talked about the key ingredients, but how do they actually all come together to give concrete its remarkable properties?
Well, that's where the mix design comes in, and that's what we're going to be diving into next.
All right, I'm ready to get into the nitty-gritty of concrete mix design.
Let's do it.
Welcome back to the deep dive.
So we've met the players in concrete. Now we got to figure out how to actually put them all together.
Right, that's where the mix design comes in.
Yeah, and this handbook, it lays out a whole system based on Indian standards.
Yeah, it's pretty thorough.
So what are they trying to achieve with this mix design? What's the goal?
Well, it's all about finding that balance. You want concrete that's strong and durable,
Right.
but it also has to be workable. Like, you need to be able to actually pour it and place it. And I imagine cost is a factor too, right?
Oh, yeah, definitely. You don't want to be using way more cement than you need.
So how do they actually go about designing the mix?
Okay, so the Indian Standard Method, it starts with setting a target mean strength for the concrete.
Okay, so that's like, how strong do you need it to be?
Exactly, like, how much weight does it need to support?
Right.
And then they take into account things like the maximum size of the aggregates
Uh-huh.
and the workability you want.
Okay.
And all that goes into figuring out the optimal water-cement ratio.
Right, because we talked about how important that ratio is.
Yeah, too much water and the concrete's going to be weak too little, and it'll be like trying to mix rocks.
Yeah, I can imagine that wouldn't be fun to work with.
Not at all.
So how do they account for all the different variables, though, like different aggregates, admixtures and stuff?
Well, the Indian Standard Method, they use this thing called the dry rotted unit weight of the coarse aggregates.
Okay, I'm not sure I follow. What's that?
So basically, imagine you fill a container with gravel and you shake it down to compact it.
Okay.
That measurement tells you how densely the aggregates can pack together.
So it's like how much space they take up.
Exactly. And that then guides how much fine aggregate and coarse aggregate you need.
You get the right volume and workability.
Right. And the handbook has all these tables and charts to help you with the calculations.
So there's some serious math involved.
Oh, yeah, for sure. But it's not just about plugging numbers into a formula.
Right. I imagine experience comes into play, too.
Definitely. Like, even the fineness of the sand can make a difference.
Oh, really?
Yeah. And you might need to tweak the mix depending on what you're building.
So like a slab versus a column or something.
Exactly. The handbook really stresses that you got to adapt the mix design to the specific conditions.
Okay, so it's like having a recipe, but with room for adjustments.
Yeah, that's a good way to put it.
What about extreme conditions, though? Like, we talked about how hot and cold weather can affect concrete.
Yeah, that's a whole other challenge.
So what do they recommend for dealing with those situations?
Well, in hot weather, the main problem is that the concrete sets too quickly.
Right, because of the heat.
Exactly.
Yeah.
And that can lead to all sorts of problems like reduced workability, cracking, even lower strength.
So it's like the concrete is rushing to harden before you're ready.
Yeah, basically. So to deal with that, they recommend a few things.
Like what?
Well, controlling the temperature of the materials is key.
Okay.
So using chilled water, keeping the aggregates shaded, stuff like that.
Makes sense.
And then there are admixtures called retarders that can slow down the setting time.
Oh, right. So that gives you more time to work with it.
Yeah, and proper curing is super important too, but we'll get to that later.
Okay, so it's a multi-pronged approach to keep that concrete happy in the heat.
Pretty much.
What about cold weather? What are the challenges there?
Well, in cold weather, it's the opposite problem. The concrete sets too slowly.
Right, because it's cold.
Exactly, and that can delay strength development, and if it gets too cold, the concrete can freeze before it's fully hardened.
And that'd be bad.
Yeah, that could cause serious damage. So they recommend a few things for cold weather, too.
Like what?
Well, they often use heated enclosures or insulate the formwork.
Oh, so basically keep it warm.
Yeah, give it a cozy little environment to cure in.
I like it.
And you can also add accelerators to the mix.
Which speed up the setting.
Right, and remember those air and training agents we talked about?
Yeah.
They can actually help prevent damage from freezing, too.
Oh, how so?
Well, they create tiny air bubbles in the concrete.
Okay.
And those bubbles give the water space to expand when it freezes.
So it doesn't crack the concrete.
Exactly. Pretty clever, huh?
Yeah, that's really cool.
So yeah, dealing with extreme temperatures, it definitely adds another layer of complexity.
It's amazing how much thought goes into adjusting the mix for these different conditions.
It really shows that concrete isn't just one size fits all.
Okay, so we've talked about the mix design and all the factors that go into it.
Right.
But how do we actually know if the concrete we've made is any good?
That's where testing comes in, which we'll get to in the final part of our deep dive.
All right. Can't wait to see how they put this concrete to the test. All right, so we've talked about the ingredients, we've talked about designing the mix.
Yeah.
But now we got to make sure the concrete actually lives up to its potential.
Exactly. We got to make sure it's the real deal, not just some wannabe concrete.
So how do they do that?
Testing.
Testing.
Okay, so this handbook obviously emphasizes quality control.
Yeah, big time. They actually test the concrete at different stages.
So it's not just a one-time thing at the end.
Nope, it's like a constant monitoring process.
Interesting. So where do they start?
Well, they start by testing the fresh concrete right after it's mixed.
Okay, so what are they looking for at that stage?
A couple of key things. First, they check the workability.
Workability, so like how easy it is to work with.
Exactly like how easy it is to pour, place, and finish.
I can see how that would be important.
Oh, yeah. You don't want to be wrestling with concrete that's too stiff.
Makes sense. And what else?
Setting time. Oh, so like how long it takes to harden.
Yep. That's crucial for planning the construction process.
Right. You got to make sure you have enough time to work with it before it's set.
Exactly. And they also do a visual inspection of the fresh concrete,
Oh, okay. Why is that?
just to check for consistency and make sure there's no segregation.
Right. Segregation.
Yeah.
That's when the ingredients start to separate.
Yep, like the aggregates sinking to the bottom.
Which is bad because...
Weakens the concrete, creates inconsistencies. You don't want that.
So it's all about making sure it's a nice uniform mix.
Exactly. Got to have all the ingredients playing nicely together.
Okay, so that's the fresh concrete, but then obviously the real test is once it hardens.
You got to The hardened concrete is what actually has to carry the load.
So how do they test that?
Well, the big one is the 28-day compressive strength test.
Okay, what's that all about?
So they cast these concrete cubes,
Okay.
cure them carefully, and then after 28 days, they crush them.
Whoa! Literally crush them.
Yeah, in a special machine to see how much force they can take.
Wow. That's a serious test.
It is. It's the gold standard for measuring concrete strength.
And this makes sure that the concrete meets the design requirements.
Exactly. And the handbook, it outlines all the procedures for doing this test very precisely.
So it's a standardized thing?
Yep. Got to make sure everyone's doing it the same way.
So that's pretty intense. But is that the only test they do on hardened concrete?
Sometimes they need to go a step further and test the concrete in the actual structure.
Oh, wow. So like in a bridge or a building?
Exactly, because sometimes there are factors in the field that can affect the concrete's performance.
Right. Things you can't necessarily replicate in the lab?
Yep, and that's where core testing comes in.
Okay. So what's that?
They actually drill out these cylindrical samples called cores from the structure.
Oh, wow. Right out of the concrete.
Yeah, and then they test those cores for compressive strength.
So it's like getting a sneak peek into the concrete's inner workings.
You could say that it gives you a more accurate picture of how the concrete is performing in its real-world environment.
So this core testing, it's like a checkup for the concrete.
Yeah, basically like making sure it's still healthy and strong.
Makes sense. So it seems like testing is a really crucial part of the whole concrete process.
Oh, absolutely. From start to finish, you got to keep testing to make sure you're getting what you expect.
And all this testing, it really shows how much emphasis they put on quality control.
Yeah, for sure. They don't mess around when it comes to concrete.
Well, I gotta say, this deep dive has been eye-opening.
Yeah, it's one of those things we see every day but don't really think about.
Totally. But now I'm like looking at concrete with a whole new appreciation.
It's pretty amazing stuff when you really get into it.
It is. It really is. So what's the biggest takeaway for our listeners today?
I think the biggest takeaway is that concrete isn't just some simple mixture. It's a carefully engineered material with properties that can be tailored to all sorts of different applications.
Right. And all the testing that goes into it, that's really crucial for making sure we have safe and durable structures.
Definitely, it's all about understanding those properties and controlling the quality so we can build things that last.
Well said. It's been a fascinating journey exploring the world of concrete.
Glad you enjoyed the deep dive.
Definitely. Until next time, keep exploring, keep learning, and as always, keep diving deep into the world around you.
See you on the next one.